Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. Today I am going to discuss about the part 2 of the video of the wave optics. So I will basically I will cover two topics, that is reflection on the basis of the wave theory as well as refraction on the basis of the wave theory, as well as I will also prove Snell's law. Now let us consider reflection on the basis of the wave theory. So reflection means angle of incidence must be is equal to angle of reflection. Now let us take some of the conditions so that we can understand that what is actually happening. Now let us use this. So this is your interface, or this is your reflecting surface, right? So this is your reflecting surface. Now we know that for parallel beam of light, the wave front will be always plane. I have already discussed in the previous class, right? Or a previous video, you can refer there. So let us consider a wavefront of parallel beam of light. So this is your wavefront of the parallel beam of light. Now what is angle of incidence? Angle of incidence is the angle made by wavefront from reflecting surface. Okay, so here this is your angle of incidence, so definitely this is your angle of incidence, right? Now let us create a normal. So let us put here normal. So let it be normal at this point. This is your normal surface, right? Now what will happen if you consider this as a point A, this is point A, and this is point B. So this both and whole AB will be a wavefront, and this each and every point of this AB act as a will act as a source of light. So what will create? It will create some disturbance. But as soon, see here, this B will create a disturbance like this. So this B will create a disturbance like this, like this, like this, like this, like this. The time, not the time at which the B will reach here. So let us discuss it. So let us consider B has reached here, and we have a point, that is B dash, at this point. So this is your B dash. So the distance traveled at the C, distance traveled by A will be same. Distance traveled by A, wave disturbance being created by A. Let us consider this this. So definitely this will create some disturbance, like right this. Or I can just use the different color so that it will be more helpful for you. So let us use different color. So this is your color. So see here, this will in return, so as it will return back, right? So this will create a disturbance like this will create a disturbance like this, and like this, right? Like this. Okay, now what will happen at the same time? For example, let us the time taken to reach from B to B dash, is t. So time taken from to reach from A to A dash will be also t. So let us consider here A dash. So this is the point A dash. Now we need to take a common tangent to both. So if you will take common tangent to both, so what we will get here? So we will get here like this. So this is the common tangent, and we will get this one, right? So this is perpendicular because it is common tangent. Now we have a two triangle, right? So from here we can basically say that B into B dash, the distance B into B dash is equal to speed of the light into time t, right? As well as distance A dash will be also again C into t, that is speed into time, right? One more thing we have observed that angle in triangle in triangle A B and B dash and A dash and B dash. If you observe these both triangles, so what happens? This angle ABB dash is equal to angle A dash B dash, that is equal to 90 degrees. So this is one angle which angles are equal, right? So AB dash is equal to AB dash because same side, okay, right? And the one more thing we need to find it, that the angle which is being created by this. So let us suppose the angle being created by the secondary wavelet of the A dash as well as B dash will be how much? This will be R. So let us consider this as a R. Now A and A dash. So what happens? We find that both our triangles are similar because one angle is 90 degree, one side is same. So what we can say that, and one side is same, that is A B dash is equal to B dash, and one more thing is that B dash is equal to A dash, B dash is equal to A dash is equal to C into time T, right? So both the triangle are congruent, both the triangle are congruent, right? If both triangle are congruent, so we can definitely say that the angle BA B B A B dash is equal to angle A dash B dash into A. So this both angle will be same, and this is equal to I, and this is equal to angle R. So this is the behavior, and this is the proof of laws of reflection. I hope you have understood this, right? Now similarly we will discuss about the next point or next topic, that is refraction on the basis of the wave theory and Resnel's law proofs. Okay, so what we need to understand that how refraction happens. So let us create some interface. So let us understood that this is our interface, right? This is our interface, okay, and these mediums are transparent medium, but it has different density, okay. So let us check what is the, let us represent mu1 is the refractive index of medium 1, and it's a rarer medium, and the velocity of the light will, let us consider it is as v1. Now this one it has a refractive index of mu2, and this is your denser medium, and its velocity velocity of the light in this medium, let us be v2. Why? Because velocity will change, right? Velocity will change, right? So definitely velocity is going to change here. So this is the surface, this is your interface, this is your interface. Got it? Now one more thing we have already studied, that mu is equal to c by v. So from here mu1 is equal to c by v1, and mu2 is equal to c by v2. Got it? Now from where, when we divide it, so what we can get here, mu2, from here we can get mu2 divided by mu1. So if you divide mu2 divided by mu1, so both are inversely proportional to the velocity, but both have a common c. So what we will get, this will be equal to v1 by v2. So this is one of the thing we should consider, right? So I hope you have understood. Now let us put wave. So let us consider a wave. This is a parallel beam of light. This is a parallel beam of light. Let us again check it. So it's a parallel beam of light, right? its parallel beam of light. This is point A, this is point B, got it? And the angle of incidence from this, we have already discussed that what is an angle of incidence, right? A light rays is coming. If you talk about the light rays, so light rays definitely which is perpendicular to the wave, perpendicular to the wave front. So let us make it as a perpendicular to the wave front so that we can understand. So let us consider the light is coming like this. Got it? So light is coming like this. Light is coming like this, right? And it is making an angle like this. I hope you have understood. Now let us create a wavelet. So secondary wavelet, tertiary wavelet. So definitely this is creating a disturbance. So what will happen? It will create a disturbance like this, like this, like this, like this, and like this, and like this, and like this. So let us consider this is the B dash point. And if you talk about the distance table, so if you talk about the distance table by this light will be this, right? So distance table, can we write this distance table as velocity v1 into time t, and for that same time, for the same time period, what is the disturbance is being created by the A. So A, let us consider A, since now what happens, now the wave will travel with the different speed. Now you may ask that, sir, why this is happening? See, earlier when medium was rarer, so speed of the light was faster, but as the medium was denser, so speed of light becomes slower, that is velocity becomes lower. So when velocity becomes lower, so its distance travel will be less, definitely. So A dash, so for the same time, the distance travel for the same time from A to dash, A dash will be this one, and this one we can consider as velocity v2 into time t because the time period is same. Now, if we draw the tangent to both A dash as well as B dash, so what we are going to get next wavefront after refraction. So let us consider this is the wavefront. So A and A dash is the wavefront. Now what is the angle made by the wavefront? So definitely angle made by the wavefront is R, right? So I hope you have understood this all this concept, right? Now let us consider this triangle. In triangle AB B dash sine I. See here, all are perpendicular. Light rays is always perpendicular to the wavefront. So this is also perpendicular. So in, see, we can observe that sine of angle of incidence I, that is I, is equal to perpendicular by hypotenuse, that is equal to BB dash divided by hypotenuse, that is equal to AB dash. AB dash. Now what is the value of BB dash? So we can write here V1 into T, V1 into time t divided by a b dash. Now one, this equation we have got equation 1. Now this is your sine r. So sine r is equal to perpendicular by again hypotenuse. So perpendicular is a dash. So this one is the perpendicular. So definitely a into a dash divided by hypotenuse means a b dash. A b dash. So a dash means v2 into t divided by a b dash. So this is equation 2. Now divide equation 1 by 2. So when you divide equation 1 by 2, so what we will get? We will get sine of incidence of I divided by sine of angle of R. So this is equal to V1 into tau divided by AB dash divided by V2 into tau divided by AB dash. So AB dash got cancelled out, tau got cancelled out. So finally we have got V1 by V2. Now if you talk about this one v1 by v2, so from this equation A, so what we will get, sine I divided by sine R is equal to mu2 by mu1, or we can say that mu1 sine I is equal to mu2 sine R. So this is our Snell's law. Hence Snell's law proved. Hence Snell's law proved. Okay, so I hope you have understood this equation and you have enjoyed our classes. Thank you for watching video, and if you have any query, just ask me, and you can visit other videos playlist. I hope it's okay. Thank you for attending.